Think back to a medieval world brimming with heavy theological discussions and complex debates, a time when scholars, shrouded in their cloaks of tradition, are hungrily searching for deeper meaning in the chaos of existence. Then, along comes William of Ockham, cutting through all the clutter with a powerful new idea. His idea, the simple answer, is usually the right one. Ockham believed there was no use engaging in these endless debates. Rather, when confronted with competing explanations, people should accept whichever explanation is the simplest. This principle came to be known as Occam's razor. But who exactly was William of Ockham, and why did his razor cut so deeply through centuries of intellectual tradition? Let's unravel the story of the man who believed that the best answers might be the simplest, and discover how his work still guides science and philosophy today. William of Ockham was born in England in the late 13th century. He became one of the most influential and rebellious thinkers of the High Middle Ages. He did not follow the path of other philosophers of his time, like Thomas Aquinas and John Duns Scotus. Instead, Ockham was notorious for his sharp critiques of the Church and his controversial theories about logic and metaphysics. Occam's razor is, at its core, about simplifying and eliminating unnecessary explanations. It was inspired by Occam's broader views about philosophy, particularly his opposition to the metaphysical complexities favored by his contemporaries. Unlike many of the great scholastic thinkers of his time, Ockham advocated for a more minimalistic approach to understanding the world. He sought to strip away unnecessary ontological baggage that added nothing to our understanding of the world. Occam's view was clear. If you don't need an entity or an explanation, don't include it. He applied this approach not just to the natural world, but also to more abstract questions about theology and philosophy. Ockham was especially concerned with the concept of universals, a central issue in medieval philosophy and theology. Realists, inspired by the Greek philosopher Plato, had long argued that a universal was a real, independent entity, a quality that existed independently of our experience. For example, the concept of goodness exists as an objective thing that is just as real as any physical object. For the realists, if goodness exists as a universal, it's a quality that transcends any specific instance of goodness. It could be found in any good thing, whether a kind act or a virtuous person. Though goodness may seem abstract, it is still an actual, tangible entity in the realist view. Ockham, on the other hand, considered himself a nominalist. Nominalists contended that universals did not exist as separate entities. Rather, they were just words, labels that people applied to different things based on shared characteristics. In Occam's time, to say that moral qualities are just terms people made up, rather than universal truths from God, was beyond controversial. It was heretical. The realist view tied abstract concepts like goodness directly to divinity, but the nominalist view dared to suggest that so-called moral truths might simply be the product of human minds. It raised high-stakes questions about the authority of the Church and the nature of divine knowledge. You might think that Occam's razor was directly coined by Ockham himself, but as it turns out, Ockham never actually used the term Occam's razor to describe his ideas. Additionally, the quote, "Don't multiply entities beyond necessity," is often attributed to Ockham, but he never said those exact words either. Occam's work, in reality, was more nuanced. His writings show that he favored simplicity, but he didn't flat out deny the existence of universals either. And it wasn't until a few centuries later that the term Occam's razor was introduced by an Irish friar named John Punch, who described Occam's approach as a razor that cuts away unnecessary complexity. So, how has Occam's razor been applied to scientific inquiry over the ages? New theories often come with baggage, all sorts of assumptions and lots of ideas that are meant to explain the phenomena in question. Occam's razor reminds us of the value of simplicity amidst this chaos. Take the historical example of Galileo. the Italian astronomer who emerged during a time of conflict between the Ptolemaic and Copernican systems of astronomy. Ptolemy, the ancient Greek scientist, had heaped a series of complex explanations upon his geocentric model of the solar system, in which the planets were said to orbit around the Earth. Nicholas Copernicus later introduced the heliocentric model. At the time, this was a radical departure from the norm, but the planet's orbit around the Sun proved to be a simpler, more straightforward, and ultimately more accurate system. Galileo controversially championed Copernican astronomy. "Nature does not multiply things unnecessarily," said Galileo. "She makes use of the easiest and simplest means for producing her effects." The influence of Occam's razor only grew stronger from there. Over time, scientists and philosophers moved away from the speculative and complex metaphysical ideas that had dominated the previous centuries. Instead, they favored the clarity of simpler explanations across fields of study. Occam's razor has since shaped the course of countless scientific discoveries. For instance, take the work of Antoine Lavoisier, the father of modern chemistry. In the 18th century, Lavoisier helped debunk the theory of combustion, which had suggested that a mysterious substance, called phlogiston, was released during chemical reactions. Lavoisier's experiments, however, showed that combustion actually resulted from a measurable chemical reaction with oxygen. The rejection of phlogiston wasn't just an experimental breakthrough, it was also a victory for Occam's razor. Lavoisier removed the unnecessary, complicating concept of phlogiston from chemistry, creating a simpler and more accurate understanding of combustion. By applying Occam's razor, Lavoisier cleared the path toward modern chemical theory. From Ockham to Galileo to Lavoisier, you can see how the stage has been set for scientists to keep on challenging the status quo and to look past overly complex and unfounded assumptions. In this way, Occam's razor has helped create a more rigorous and systematic approach to scientific inquiry that we still use today. So, let's fast forward to the present day. Occam's razor is as relevant as ever, especially in the field of artificial intelligence. One of the most significant challenges we're facing in AI and machine learning is avoiding overfitting, a situation in which a model becomes so finely tuned to its training data that it fails to generalize new data. Here's where Occam's razor comes in. Simpler models with fewer assumptions and less complexity are easier to manage and end up performing much better data analysis. They're better at identifying underlying patterns without getting bogged down by the extra noise. This principle is at the heart of AI optimization. Simplicity makes models more interpretable and more efficient. So the value of Occam's razor is clearly timeless. It encourages us to stay grounded in the power of simplicity as we advance technology and develop more innovative systems. But despite its historical importance, Occam's razor is not without its modern-day critics. Some argue that its preference for simplicity might lead us to overlook complex yet crucial aspects of scientific truth. As humans with natural limitations, we may become too biased towards simpler theories and hypotheses. Nevertheless, for centuries, Occam's razor has led us towards simpler, better answers in philosophy, in science, and even in the everyday challenges that we face. In a world that's rapidly evolving right before our eyes, it's easier than ever to get lost in the noise of complex theories and abundant over-explanations. From ancient debates over universals to the modern-day expansion of AI technology, Occam's razor has been a constant presence, helping us cut through the complexity to find the clarity we need to succeed.